In our lesson 4 notes in our trigonometry unit for Algebra 2, we're going to dive into some more trig functions. The trig functions that we're going to add to the mix today are the cosecant, secant, and cotangent trig functions. So we've already looked at the sine, cosine, and tangent functions, and we have looked at the ratios, right? X over r, y over r, y over x. So what do I mean by this? I mean that we've already looked at, let's say I have an angle measure in standard position on the coordinate plane. When we've talked about those coordinates, we know, let's say I have an angle that looks like this, and I know this to be r. Right here, how do I get to this point up here? I know that, you know what, let's do this. I've got a right angle here, a right triangle. I'm going to move along the x-axis to get to this point, and then I'm going to move up however many units to show this ordered pair, which would be x comma y. Okay, and we've looked at that I can get that point from a right triangle, right? I've got all these triangles shown, on this coordinate plane. And then we've talked about trig ratios, the sine, cosine, and tangent functions. So you may recall the sine of theta, this being my angle theta, the sine of that would be y over r, okay? Which means when I have an r value of 1, which I do on my unit circle, the sine is just the y value. The cosine of theta is x over r. When r is 1, as the radius is on my unit circle, right, it's the 1 unit, right, that's my r value, then the cosine is just the x value, the cosine of that angle measure. And then the tangent of theta is y over x. So these are things that you need to memorize. Okay, these are the trig functions, y over r, x over r, y over x. Those are my trig ratios. And now we're going to add cosecant, secant, and cotangent. And these are called reciprocal trig functions. So the cosecant trig function is the reciprocal of the sine trig function, which means the cosecant of theta, which I've shown to be like this angle measure right here, we'll call this angle measure theta. The cosecant of theta is going to be not y over r, but r over y, or 1 over the sine of theta, okay? 1 over sine. And then the secant of theta is the reciprocal of cosine theta, which means the secant of this degree measure right here, instead of being x over r, is r over x. Or I could say 1 over cosine. And then cotangent, you've got it, is the reciprocal of the tangent function, which instead of y over x is x over y. Or instead of sine over cosine, it's cosine over sine. So I really like to, when I'm thinking about trig functions, I'm thinking of the y, is sine. When I think of cosine, I think of x, tangent, y over x, and then if I really know those trig functions, sine, cosine, and tangent, I know my reciprocal trig functions, cosecant, secant, and cotangent. You just have to remember which ones match up with which. Like cosecant is the reciprocal of sine, okay? And once you can memorize at least one of those, then you can figure out the others. So now let's talk about trig functions of general angles. And in this case, we're going to look at these additional trig functions that we've added to the mix today. In today's lesson, I want you to use your unit circle. So if you need to, get out that unit circle and, refer to that as we're going through this, which you should have a copy of, or you can look at yesterday's lesson. I'll put a little card in the upper right corner, and that'll link to yesterday's lesson, which shows our unit circle. So this says, find the exact value of each trigonometric function. Number 1 says cosecant 9 pi over 4. Okay, Well, what is this? First, let's talk about what this is coterminal with. I know that 8 pi over 4 would be all the way around, right? All the way around is 8 pi over 4, which is 2 pi. 9 pi over 4, I'm adding another pi over 4, which means this right here is coterminal with pi over 4. So when we're looking at our unit circle, let's look at pi over 4. Pi over 4 is my coordinates are the square root of 2 over 2, comma, the square root of 2 over 2. Cosecant is going to be 1 over the sine of pi over 4. It's the reciprocal. I flip it, okay? Which means that's the same thing as 1 over, what is the sine of pi over 4? What is the y value at pi over 4? It's the square root of 2 over 2. So I'm doing 1 divided by the square root of 2 over 2. Well, that's going to be 1 over 1. How do I divide fractions? I multiply by the reciprocal. So I'm going to flip it. 2 over the square root of 2. So I get 2 over the square root of 2. But can I leave it like this? I cannot. I need to rationalize the denominator. So I'm going to get 2 times the square root of 2 over 2. And now I can simplify it even further. Those can be eliminated, and I'm left with the square root of 2. So cosecant 9 pi over 4 is the square root of 2. That is the value of that trig function at 9 pi over 4. Let's move on to number 2. Secant of negative 210 degrees. Negative 210. Well, what is that coterminal with? It's coterminal with 150 degrees. This is coterminal with 150 degrees. So if I were to move, negative 210 degrees, right? I'm like up here, right here. Whoop, let's say I'm right there. That's negative 210 degrees. It's like 30 more right here from 180, right? Which means this way around, I'm at 150 degrees. So on your unit circle, I want you to look at the x and y values for 150 degrees. What's the cosine of 150? The cosine of 150 is negative 3, or the square root of 3 over 2. So the secant, remember, that is the reciprocal of cosine. So the secant of negative 210 is the same thing as 1 over the cosine of, I can say negative 210, but if I'm using my unit circle, I know the value of cosine at 150 degrees. I can easily see that on my unit circle. Well, the cosine of 150, that's the x value, is negative square root of 3 over 2. So I'm going to do 1 divided by negative square root of 3 over 2. And if you need to pause the video and look at, those values that I'm talking about, because I'm not showing them right here, go ahead and do that. Okay, so the cosine of 150. So now I'm just doing some math. I'm taking 1 and I'm dividing it by negative square root of 3 over 2. That's the same thing as 1 over 1 times, and I flip it 2 over, or negative 2 over the square root of 3. So let's show this down here. I get negative 2 over the square root of 3. But can I leave it like that? I can't. I need to rationalize the denominator. And I get negative 2 times the square root of 3 over 3. And that's the value of secant of negative 210 degrees. Let's move on to our third example here. We're looking at cotangent of 210 degrees. So what's the ordered pair at 210 degrees? On your unit circle, go ahead, pause the video, find that ordered pair at 210 degrees. It's negative square root of 3 over 2, comma, negative 1/2. Okay, if I were looking for the tangent of 210 degrees, it'd be y over x. That'd be negative 1/2 divided by negative square root of 3 over 2. The cotangent is going to be x over y, which is negative square root of 3 over 2 divided by negative 1/2. That's the same thing as negative square root of 3 over 2 times, and then I got to flip it, negative 2 over 1. And now we're just multiplying fractions, which in all honesty, this is what I find to be really challenging with Algebra 2 students. Just or where a lot of mistakes are made. So maybe not challenging at first, but a lot of times if I find errors and problems, it's like a problem with this kind of stuff. So, and it's just, typically when I show students, it's like, I go, oh, yeah, why did I do that? And honestly, I do the same thing. So, negative square root of 3 over 2 times negative 2 over 1. I can simplify by crossing out those 2's. Negative 3, or negative square root of 3 over negative 1 is just the square root of 3. So that is that value, the square root of 3. Let's move on to number 4. Number 4, and I think the rest of these are going to go fairly quickly. So number 4 says, find the exact values of all 6 trig functions for theta if theta is an angle in standard position and contains the point negative 6, 8. Okay, well, let's draw a picture. You got to draw a picture. You have to visualize this. I know that this angle is in standard position, which means I know right here the vertex is at the origin, and I know it contains the point negative 6, 8. Where is that point located? Negative 6, 8. That point is up there, okay? Which means, right here, this right here is negative 6, and this right here is positive 8. So that lets me know the quadrant that it's in, okay? If I am looking to find the value of all 6 trig functions, I need to know the length of this hypotenuse, right? This is a triangle, and I know that I can find the length of a missing side of a right triangle using the Pythagorean theorem. A squared plus b squared equals c squared. So negative 6 squared plus 8 squared is going to be my radius squared. Negative 6 squared, that's 36. 8 squared is 64, equals r squared. That means 100 equals r squared. I take the square root of both sides, and I get the radius to be 10. So the hypotenuse, or radius, we can call it, of this triangle is 10. Now we can figure out our the values of our 6 trig functions. So I'm going to do sine of theta, I'm going to do cosine of theta, and then I'm going to do tangent of theta. Let's do these first. So sine of theta, y over r. Y is 8, r is 10. That's 8 over 10, which simplifies to 4 over 5. The cosine of theta is x over r. That's my trig ratio, right? X over r, which is negative 6 over 10. Negative 6 over 10 simplifies to negative 3 over 5. And then tangent of theta is y over x. And if you need to, like, write y over r, x over r, y over x, you can do that. Tangent of theta is 8 over negative 6, which simplifies to negative 4 over 3. And now let's do our reciprocal trig functions. Cosecant is the reciprocal of sine. I'm going to write it next to this. So the cosecant of theta is not going to be y over r. It's going to be r over y, which is 10 over 8, which simplifies to 5 over 4. And hopefully now you can see that they are reciprocals, right? That's 4 over 5. That's 5 over 4. Let's move on to the next one. The secant of theta is the reciprocal of cosine. The secant, instead of x over r, is r over x, which is 10 over negative 6. That's going to be negative 5 over 3. And as you can see, these are reciprocal values, right? We're not changing sign. Like reciprocal is just you flip it. And then the cotangent of theta, that's the reciprocal of tangent theta. Instead of y over x, we're going to look at x over y, which is negative 6 over 8, which simplifies to negative 3 over 4. And as you can see, again, this is negative 4 over 3. This is negative 3 over 4. Those are reciprocals. Let's move on. Number 5, it says finding exact values of trig functions. If sine of theta equals 7 over 9, find the remaining 5 trig functions if theta is an angle in standard position whose terminal side lies in quadrant 2. Okay, well, let's sketch it. Okay, we know that it's in standard position. We know the vertex is at the origin, and I know that sine of theta is 7 over 9. I know sine to be y over r. So, and I know that it lies, the terminal side lies in quadrant 2. So, 7 over 9, if that's y over r, let's just say we got this, y over r, that means that this right here is 7, our r value is 9, and we're missing this x value. So we need to find the length of this side of our right triangle. All right, so we're given this trig function. All right, we know it lies in quadrant 2. We know that the trig ratio for sine is y over r, so that's that vertical distance, if you will. And then we know the radius of this particular angle measure, which if we put it on a circle, right, we call it a radius, is 9. So how do I find the length of the missing leg of this right triangle? Well, I know that leg squared plus 7 squared is going to equal the hypotenuse squared. Okay, well, let's just do some basic algebra. 7 squared is 49. 9 squared is 81. If I subtract 49 from 81, I get 32. So if x squared is 32, then x is the square root of 32, which I need to simplify this non-perfect square root. So the square root of 32 can be simplified in the square root of 16 times the square root of 2. The square root of 16 is 4. So that's 4 square roots of 2, or 4 root 2. So the length of this missing side is 4 root 2. And now we're asked to find the remaining 5 trig functions. So we know sine. Let's find cosine theta and tangent theta. Cosine theta is going to be x over r, which is pretty simple. Oh, you know what? This should be negative. I didn't write that, right? If it's in the second quadrant, this x value right here is negative. So cosine theta is going to be negative 4 root 2 over 9. Tangent theta is going to be y over x. That's 7 over negative 4 root 2. Well, I can't have a square root or a radical in my denominator, so I need to rationalize it. So I get negative 7 root 2 over negative 4. If I remove that radical, right, I just get 2. So negative 4 times 2 is negative 8. And I've already got my negative right here. So there's my value, 7 root 2 over 8. So now let's find our other trig functions. Cosecant theta, secant theta, and cotangent theta. So cosecant theta, that's the reciprocal of sine, which instead of y over r is r over y, which is 9 over 7. Secant theta, it's the reciprocal of cosine, so instead of x over r, it's r over x, which is 9 over negative 4 root 2. I need to rationalize that denominator, so I'm going to put the negative out in front because I like to do that. Negative 9 square roots of 2 over 4 times 2 is 8. Cotangent theta, Instead of y over x is going to be x over y. So I get negative 4 root 2 over 7. And I don't need to rationalize any denominator because I don't have a radical in my denominator. So let's move on to the very last section of today's notes, and we're going to look at behaviors of trig functions in the quadrants. So I've got your trig functions here, or your trig ratios that you can reference, because, I mean, you'll just work with these a lot and you'll eventually memorize them, but I can see how, it can be kind of confusing at first. So what are these functions, like the sine of theta, cosine of theta, where are they positive and where are they negative? Okay, when we talk about the sine values, okay, of angles, we're talking about the y values. Where are y values positive and where are y values negative? Well, y values are positive above the x-axis, which means sine values are positive above the x-axis. They are negative below the x-axis. So down here in quadrants 3 and 4 are where those sine values are going to be negative. Now let's talk about cosine values. Where are cosine values positive and where are they negative? Cosine values are the x values. They're going to be positive to the right of the y-axis. They're going to be negative to the left of the x-axis. So, if we talk about like ordered pairs, here's what they look like, right? Here's our ordered pairs, where they're positive and where they're negative. So where are cosine values positive? Okay, those are the x values. Where are sine values positive? Those are the y values. Where are they positive and where are they negative? And now we can talk about our tangent functions, right? So tangent functions are y over x. Where are our tangent functions positive? Our tangent functions are going to be positive when the x and y values have the same sign, right? A positive divided by a positive, that's positive. A negative divided by a negative, that's a positive. Our tangent functions are going to be negative where our x and y values are opposite. So a positive divided by a negative, it's negative. Negative divided by a positive, that's a negative. So these are the behaviors of the trig functions in the quadrants. And you'll need to kind of, you can think about this whenever you're given a word problem or just some information on a problem. For example, in our last problem here, if cotangent of theta is 3 over 4, find all possible values of sine theta and secant theta. Okay, cotangent theta is 3 over 4. So instead of y over x, we're looking at x over y, which I should have just done this. We're looking at x over y, which we're still dividing, right, our two values here. So we're looking at where those two signs, our x and y values, are the same. Okay, so if cotangent theta is positive, where is tangent theta positive? In our first and third quadrants, which means right here, we know cotangent theta to be x over y. If that's 3 over 4, then I know I'm going to go out 3 and up 4 to get this point, right? And I know I could go left 3 and down 4 to get this point, okay? Those are where my values are going to be derived from. So now, and you might be able to see that this is a Pythagorean triple, right? It's going to be a 3, 4, 5 triangle. You may recall that. If you don't, you can use the Pythagorean theorem to find the length of each hypotenuse, right? Which is going to be the same. I know that a squared plus b squared equals 3c squared. So 3 squared plus 4 squared is going to equal my radius squared, or c squared. 9 plus 16 equals r squared. 9 plus 16 is 25. And I know when I take the square root of both sides, I get 5. which means the length of this is 5 and the length of this is 5. That's always going to be positive, okay? So now let's look at our possible values of sine and secant. So sine theta, recall that it's going to be y over r. So I know that a possible value of sine theta could be 4 over 5 right here, right? It could be 4 over 5, but sine theta could also be negative 4 over 5. Those are the possible values when I'm given the information that I was given in this particular problem. Find all possible values. So I know cotangent theta is positive. I know the ratio is x over y, and I've put those in place on this little sketch that I've drawn. Now let's look at secant theta. Secant theta, that's the reciprocal of cosine. So instead of x over r, it's r over x. So secant of theta could be 5 over 3, but secant theta could also be 5 over negative 3. So those are the possible values of sine theta and secant theta when we're given this information, which I know we kind of have to think about a lot, and you have to literally dissect each part that you're given in problems like this. So that concludes your day 4 notes over more trig functions in our trigonometry unit for Algebra 2. I hope it was helpful.